So the cloud computing has evolved from that notion of able to buy a computing device over the internet to the notion of able to lease and rent a computing device over the internet. So that's the main, you can say, per se, the philosophy about the cloud computing evolution, and you can relate that to Dell computers and going behind more years. So I always use this example of how cloud evolved. So if you look at into, say, 1980s or 70s, perhaps much before you were born, but at that time we had gramophones and audio cassette recorders when you want to listen to music, right? But over the years, in 1990s and 2000, it evolved to this Walkman and CD players, and today, if you want to listen to music, you just go to YouTube. And we can just play any music we want on the YouTube. If you want some specialized music, you can go to Spotify. There's so many apps that gives you this on-demand music based on what you want. Just either most of them are free, but some of them you can even pay for it. So similarly, cloud has evolved based on this philosophy. Instead of going and buying your own hardware and configuring it, you can just lease or rent the computing power on demand whenever you need it. And that's the core fundamental of cloud computing, being able to buy, lease, and set up your cloud hardware resources and software resources on. So you see in this picture, cloud has just not come from somewhere, right? Cloud computing is a paradigm that has evolved over the last 30, 40 years, and it has evolved from many other baseline paradigms, including mainframe computing, PC computing, network computing, internet computing, grid computing, and cloud computing. So how many of those computing paradigms do you recognize? Have you heard about this before? I mean, leave cloud computing aside, have you all heard about mainframe computing before? Obviously you have been, right? Anyone else? Right. Have you heard about PC computing or network computing? It's the same group of people who have heard about it, right? So maybe they have worked with mainframes. And so to just give a quick tour of this. So mainframe computing used to be this multi-million big computer where you used to do large-scale processing. For example, banks, Barclays and Lloyds, they used to use IBM mainframes for doing transaction processing. And what I hear, even today, when you use an ATM machine to authenticate your transaction, it goes to a back-end mainframe hosted in Barclays or Lloyds data center. So although mainframe appears at number one, it doesn't mean that with the evolution of cloud, mainframes are gone. It's not true. So the main idea of showing this picture is these are these competing paradigms that existed before cloud computing, and cloud computing inherits a lot of good features from this paradigm, but it doesn't mean that cloud computing has overtaken all the other paradigms that we show here. Those paradigms still exist. For example, grid computing, which was really popular between 2000 till now, has evolved from scientific domain where researchers from biology, chemistry, from physics, if they want to learn large-scale simulation or large-scale mathematical computation, they set up their own grid resources, and they used to club their grid resources together to do this high-performance computing, and they still exist in scientific domain. So cloud computing, which has evolved from internet computing and grid computing, has good features of the grid computing that is based on how to pool a lot of servers together, but along with that, what's the unique feature is virtualization. So how to virtualize the resources. So we will have a full lecture, a 3-hour lecture on how to virtualize physical hardware, how to virtualize a networking device. So key distinctive feature of cloud computing as compared to everything else is the virtualization. And the second distinctive feature is billing and SLA models. So in the old days, all this mainframe, PC computing, network computing, they used to be managed by enterprise, and they provide those resources to their employees. For example, Newcastle University may have some mainframe hardware that they only provide access to its own students and its own staff members, academic staff members. They never used to provide access to those hardware and software to outside world. But what has changed with cloud computing is you set up a own data center of servers and storage, you set up a billing infrastructure, and then you start selling your hardware and software to outside world. So this business model of leasing your resources to the outside world is the main philosophy governing cloud computing. Of course, to enable that, we need a lot of things. For example, we need virtualization, we need security, we need application lifecycle management, we need performance benchmarking. So our lectures will focus around those aspects which is required to manage cloud computing. Okay. So if we see in terms of the timeline, around 1960s and 80s, it was the mainframe era, and then from 2005, with the evolution of big data and MapReduce programming model from Google, we saw the evolution of cloud computing. And last 15 years, this cloud computing is growing more and more mature. So the starting provider in cloud computing was Amazon Web Services, but today, if you go and search the Google, you can have hundreds of providers offering cloud computing services. And one of the goals of this lecture is, this module is, how can you go and program and deploy application on those cloud providers? So possibly by the end of this module, you will have those skills and those understanding to be able to program, deploy, manage your application on those public or private cloud data centers. Okay, how many have you heard about Animoto gaming company? So what do we learn from this graph before I explain to you? Sorry. What does it show? So the x-axis is the time and y is number of servers. So what it is showing is that this Animoto was a startup company who used to offer gaming on demand, internet-based gaming. So when they launched their gaming, they started with almost 50 servers, like here. But over the period of time, as the game became more and more popular, they started adding more and more servers to their infrastructure. And how was that possible? That was possible because they were using cloud computing. They were using Amazon Web Services to host their gaming application. And by using the auto-scaling and elasticity feature of cloud computing, they were able to scale right from 50 servers in the peak days to almost 4,000 servers in the matter of days. They were able to scale the infrastructure almost from 50 virtual machines to 50,000 to 4,000 virtual machines. And they could do that just based on Amazon Web Services data center. So this is the power of cloud computing. So if you have an application, you can start really with a minimal number of servers. That in this case, there are 50 servers. And then as your application become more popular, your workload increases. You can lease more resources from the cloud provider, and you can scale it up as you go. As you see in this picture that, okay, at one stage they had 3,000 servers, but at some stage, when the people got saturated with their game, the demand went down, and they were able to bring down their server infrastructure to 1,000 or 1,500 servers. So this is the main cutting edge feature of cloud computing, being able to grow or shrink your application based on your workload demand, which is something which is not possible with traditional infrastructure, because you can't just buy 4,000 servers and then only have 50 of them used at any time, and then suddenly your demand comes down to 1,000 or 500 servers. So this is really impossible, if not impossible, very hard to do with the traditional IT infrastructure. But this is something which is possible by cloud computing, because your hardware and software, you don't really buy it, you lease it, and you lease it when and if you need it, okay? So this is another example that shows for this kind of workload, cloud computing is really good. So if, for example, this shows how your demand varies at different time of the day. So in the morning you have less workload, in afternoon you have more workload, then evening you have less workload. So based on how your workload is changing, you can always lease less or more servers from the cloud providers. If this was to be done in a traditional setting, then your IT manager always have to provision for the peak load, for this load, for the load in the middle of the day, which is very expensive. So, but if you use cloud computing, you don't have to do that. You just add servers to infrastructure as your demand grows over the day, over the weeks, over the years. So the main notion behind cloud computing is computing as a utility. Like, for example, if you have water, we have gas, we have electricity. Similarly, cloud computing offers you computing, storage, and networking as a utility that you can lease and purchase based on demand, and you only pay for what you use. It's fine. So before we move ahead, what do you think, where is this cloud services hosted? Do you have any thinking on that? How this ultimate scaling from 50 servers to 5,000 servers is possible? So where do you think all these 5,000 servers are hosted? Do you have any, yeah?
Like data centers.
Data centers.
Around the world, especially like in places that can pull the server.
So data centers, very good. Any other answers?
You can use them in different parts of the world, so as the time zone goes, it's busy in one area, but you can use them in another area.
Very good. So that's a very good answer. So right now, I have not checked, but we have more than 1,000 data centers around the world for Amazon, Google, Facebook, Twitter, and everyone has set up its own data centers. And it's the data center which is would be as big as this building, or even bigger than that, we host more than 100,000 servers, and they implement networking devices, virtualization to really make it cloud computing. So now we look into how data centers looks like and what's inside a data center. So before we move ahead, you think, can we do cloud computing without data centers? Can we do cloud computing without making data centers? And what do we call it if we do that? We do it in this department. They call it private clouds, or private data center. Why they say private data center? Because in that data center, they're not hosting 100,000 servers. You just have 20 servers, 30 servers, and what you're using cloud computing is just virtualization to virtualize it. So then you can also do cloud computing without a big, massive data center, just having a small scale, few blade servers, which we are doing in our group. So if you have time, if you come to office, I'll show you our cloud computing, which is just one rack, which has 80 cores. And we use virtual machines to share those resources between our PhD students. So of course, not every cloud computing requires data center, but of course on the commercial scale, when you want to offer your hardware and software to the outside world like Amazon or Azure, you need to build this football stadium scale data centers that I'll show you some pictures. Right, so this is how a data center looks like. So as you see, there are so many things in the data center in addition to servers and the storage. For example, starting with the power supply unit. You see all the things on the ground floor relates to the power supply. So because I said these cloud providers, they lease their hardware and software resource to the outside user, one of the main SLAs, service level agreement that they have with the users, that their hardware and software will be available 100% or 99.9% of the time. And what is the key factor? Having your hardware available is the power supply. So you will see on the ground floor, you will have a generator, a backup power supply, some battery storage, so that in case of a loss of actual power, this can supply power to the computing servers. What else you see here? You see air conditioning. As you know, even one laptop, if you do too much computation on that, it produces a lot of heat. And if you think that on the scale of 100,000 laptops, you will see how much heat they produce. So then cooling down the infrastructure becomes a key so that the servers can perform at the optimal level. So you will see a lot of air conditioning unit. In fact, some study has concluded that the total power bill for this Amazon and Google data center is even much more than total power bill for a city like London or Google or New York. So they are so power hungry. So that's one of the reasons why these cloud providers want to build the data center at a place where power is cheaper or the environment is cooler. So that's why a lot of people now want to build data center in Iceland, because the ambient environment is very cold, so they have to spend less money on air conditioning. And along with that, in the Iceland, they can get a lot of hydroelectric power to supply to their servers. So there's a lot of, so it's not just about having a technical solution to how to set up your hardware and software and internetwork them. If they want to make a profit, they need to save on the electricity bills and the cooling bills. So they have to figure out some mechanism how to reduce that. So now the next trend is trying to build their data centers in those parts of the world where power supply is cheaper or is cooler, so that they have to spend less money on air conditioning and other cooling devices. So on the right-hand side, you see these virtual machines. How many of you have heard of this term, virtual machines, before? So what do you think it is, virtual machines?
Yeah, it's just business that you log into online. And I used it before. It's just like just share the resources online. You can split up the resources. So if I want to run multiple virtual machines on my computer, I can have it focus with a specific.
So are you using a specific cloud provider for that?
I used a virtual machine for it, and I used MySpace to run the new version of Windows.
Right.
So mine was Pro.
Very good. So that's what virtual machines are. So for example, if this is one physical server inside a data center, if I use virtualization, I can create multiple copies of that machine, which all share the resources provided by that physical hardware. So that's why it's called virtual machine. And each one of them can have its own copy of operating system as well as its own copy of application logic. And based on how powerful is my physical host server, I can create either 2 virtual machine or 10 virtual machine or 100 virtual machine. It all depends on the hardware configuration, that is the CPU, cores, memory, networking capability of those physical host server. So after you set up your server rack and networking device, the next step is you have to install a virtual machine orchestrator, which is able to create a virtual machine across your server rack. And this is done by using something called hypervisor that we will study in lecture number 3. What is a hypervisor and how hypervisor is used to create virtual machines inside a data center. That's one way to create. The new trend to create virtual machine is containers, which is part of your coursework using Docker. So when we study both hypervisor-based virtualization as well as container virtualization, we'll be able to make a difference or different trade-offs between two kinds of virtualization technology. So one question in parallel is, given a physical server, you've got to decide how many virtual machines I want to create on top of that. How do you make that decision if you're a system engineer and you will decide that, okay, this is a rack of physical servers, and you will decide you have to create X number of virtual machines. How will you make that decision? But that's the important decision, right? Because you are going to sell these virtual machines to your customers. So you have to get that decision correct. You can't just take one physical server and create 100 virtual machines or 10 virtual machines. It's not a one round of number. So as a system engineer, how will you decide that? How many virtual machines to create per physical blade server? Any idea? That's very important, right? Because I set up a multi-million pound data center and I don't know how many virtual machines can I create and how many customers can I support. Then there is no point of having the data center. So there has to be some methodology to be able to figure out that number. Any idea? If you have done this system validation module, you must be able to answer this. Benchmarking, I think they have taught that you in that module, benchmarking, right? So you got to take your application workload, with that you want to support on that base server, and then you go to benchmark based on variable number of virtual machines and see whether one virtual machine or two virtual machine or 10 virtual machine, as the number of virtual machine grows, do I compromise on the performance in terms of response time, throughput, and latency? And based on that benchmarking experience, you will decide this particular server is capable of hosting how many virtual machines. So we have a whole lecture on that, how to benchmark a cloud server, and based on that, how to decide how many virtual machines you want to create. So that's one of the more very important steps in cloud computing. So of course, virtualization gives you power to create multiple copies of a physical machine, but it's just not infinite. A machine can't support infinite number of virtual machines, so you need to have some methodology to be able to compute a physical server can support how many virtual machines. So that is done through benchmarking, performance benchmarking. So I would suggest after the lecture, you can go to YouTube and just search Google Data Center. If you do that, it will take you to a video that shows the street tour of the data center. You can see how big is that and how the thing I'm telling you, can actually see it with your own eyes to actually believe it, what's actually inside a data center. So I would suggest after the lecture, go and try that on the YouTube, okay? So this is one picture from Google. So this is just one very small part of data center, and my friends who work in Google, they say that a Google data center is as big as 5 stadiums that we have in Newcastle Football Stadium, right? They have as big as 5 of those stadiums where they're hosting their servers and hardware and network. So big. So that's why I say inside data center they also run cars and bikes to go around the data center. It's so big. It's not just like this room where we can walk across the machines. It's so big that they have some kind of transport like bicycles or bikes inside data center. So it will be really interesting for you to go and watch that video on YouTube and see how and feel how a data center actually looks like. So as you see in this picture, what we see a data center is a big warehouse, like 3-4 football stadiums together with a lot of servers. So these all are RAID servers. So if you want to see, so what we did in our group, we have just this part. We bought one rack. So if you want to see physically how a data center looks like, you can come to our group. We'll show you one rack cabinet that we have purchased for doing our research on cloud computing IoT. But of course, in a real data center, we'll have thousands of those. But just to give you a miniature view of how data center actually built up and how these things are stitched up together to create a large data center. So we have this rack of servers where you create your virtual machines that we discussed, virtual machines where you do your computation. Then of course, if you do any kind of computation, you need to have some storage where you can store your data. So you will have storage arrays based on either network attached device or storage area network, either NAS or SAN. And then you will have cooling infrastructure, the air conditioning. Then you have power converters based on what hardware you have. You have backup generator, you have networking, you have security. So tomorrow at 12 noon lecture, we have a guest lecture on the cloud security. So where we will get more in detail how data center is made more secure. And I think these slides are already on the blackboard if you see. So we'll go through that. So as you see, a data center is a complex ecosystem of the servers, the hardware, the air conditioning, the backup generators, the network infrastructure. And as a cloud computing engineer, the question for you is, how do you program this thing and how do you deploy application on this thing? So it's not like deploying application on your laptop, right? You have to deploy and manage your application on this. So of course, if you're an application engineer, you just have to deploy. That is much easier than actually able to set up this hardware, right? If someone gives you 10 cabinets of servers and it tells you that you have to put all this thing together and make sure that it runs, that's a much harder job as compared to someone puts all this thing together, network them together using the switches and the routers and put some hypervisor or virtualization engine and then just say that deploy your web application. That's much easier job. So in the cloud stack, you have to decide where you want to work. If you want to work as a cloud administrator, then you will deal with something like that. If you want to work as a cloud application engineer, then you can just ignore all those things and you just care about cloud application deployment that you can do just by learning virtual machines and how to program the virtual machine, how to access the virtual machine. So that's much easier than actually maintaining this. But in a cloud landscape, to be able to really become a good cloud researcher or engineer, you have to know everything, right from virtual machine all the way to where these virtual machines are running, how they are deployed in the data centers, on which blade server it's running, what is the cooling impact of that, what is the energy impact of that. So you have to know all this knowledge to be able to really become a good cloud consultant or cloud engineer. So this is one of the picture of what I was saying, this Google data center is somewhere in USA. So this Google data center has more than 500,000 cores that they use to host their Google search engine, to host their YouTube services, to host their other Google Doc, all those Google services hosted on this kind of thing. Obviously, when we access these services on our browser, we don't see this complexity that I show on this slide, right? Where my Google Doc is hosted, we just don't see it. But in reality, when you create a Google Doc, you connect to one of these data centers. In these data centers creates one of the virtual machines that sits on one of those rack servers, and that gives you the service. So a lot of complicated steps goes behind the scene. So what do we call it? The steps that I described. Do we have name for that? It's called application orchestration. So based on those steps, right from setting a request for setting a Google Doc to all the way setting your Google Doc application inside a virtual machine and running on those rack servers, this whole process is called as application orchestration. And then most of the work around cloud programming at the application level is around application orchestration. How do you orchestrate your application on this massive cloud data center? So we have a lecture on that to go more in detail. What are the main programming steps involved with application orchestration and how do you go about that? And what sort of algorithms you need to do those steps correctly. That's very important. So as of now, I think Google has more than 15 data centers all around the world, in America, in UK, Ireland, Iceland, Europe, India, China, everywhere the data center based on where users are, where there's more demand for the application, it serves those applications from those data centers. For example, if there are a lot of users from UK watching some YouTube videos, they will try to serve it from their London data center. Similarly, if you have a lot of users watching YouTube videos from America, they will try to serve those content from one of those data centers in America. So why do you think they do it? Why they think they pull the proximity of data center users and try to serve the content from that particular geographic location? What could be the reason for that? So for example, you guys want to watch some video. Why don't they just serve it from US data center? Why they serve from UK? What could be the reason for that? Yeah. Network delay, right? So as you know, Google's main advantage is to say it's fast. Right? Google search is fast, right? If the search goes all the way to America, it will be much slower than going to London. So because these big IT companies, they make money on how fast they are. So they want to build data center as close as possible to the user so that you get very, very fast response time. That's why based on proximity of the users, they try to redirect your request to the nearest data center so that they give you optimal latencies for your request. For example, everyone in the world are doing Google search and all the requests are going to American data center, someone in UK will have a different latency as compared to someone in India, someone in China, and they won't be happy. But what they want to do is, if some request from India or China, they want to redirect it to some data center in India or China. If there's some request from UK, they want to redirect that request to UK data center. So that's the main motivation behind building so many data centers around the world. And right now they have more than 15 data centers based on what application they're offering. Okay, so I was saying there is so many different blade servers inside one data center. This is just a snapshot of one blade server. This is how it looks like. So you have one rack with many blade servers, and they are pretty much low-end blade servers. So if you go and Google blade server, you can see an image of that on Google. You can actually feel for it how it looks like. Those rack servers are joined to this rack cabinet, and behind this rack cabinet, you have this cluster switch that connects all those two things together, so that you can send data from one server to other server. Based on what kind of cabinet it is, the network can be 1 gigabytes per second or 10 gigabytes per second. Again, based on how much money they want to spend in the networking and the server technology, they will use different kinds of switching mechanism. So before we move ahead, what do you think could be inside a blade server? So these all are blade servers, right? They're like blades. Why they call blades? Because they don't have a display, right? There's just one blade server, though they're all arranged in this cabinet. So what could be inside the blade server? What do you think? Can we just make a rack cabinet with putting 10 laptops together? And can we call it as a blade server? So what could be inside the blade server from top of your head? Yeah? CPU and RAM. Anything else? But it has some connection to the storage somewhere, right? You need to store some data. Perhaps on the network.
Yes.
And networking, maybe networking hardware, Ethernet,
Yes.
Ethernet or Wi-Fi, or something that can connect to the switch, right? So that's a very good answer. So yeah, inside the blade server, we have CPU cores, you have memory chips, USB port, you can connect to the blade server, some networking interface, so that you can connect the blade server to external network devices as well as external storage devices. And based on how many blade servers are inside the cabinet, they use some sort of cluster switch, and that switch will have some number of ports, and those ports are again decided by how many blades we need to connect, how much is the incoming connection and how much is the outgoing connection. Then again, you got to decide your network speed based on what kind of application you want to run on this blade servers, and then you determine the network speed based on, again, network benchmarking. You have to benchmark your network to decide what kind of networking capability I need. So that's why I will keep coming to this methodology of benchmarking, because you need that at every step to decide what kind of hardware and network configuration you need in order to build your data center. So as he said, inside the blade server, you have this multi-core CPU, one core or multiple cores based on what is the capability of the blade server. For example, if you want dual core blade server from Dell, it costs 300 pounds. But if you want 16 core or 32 core blade server, it costs to 5,000 pounds. So again, it depends on what kind of blade server capability you need. It gets more and more expensive. and based on how many cores you have, it has different memory chips. This is the direct dual inline memory board that has circuit board and the RAM chips, so that they can store the data when the application running on that blade server. And then you have I/O to connect it to external USB or network interface and those. So this is like a standard, you can say a standard laptop without a display. For your understanding, you can say a blade server is a standard laptop without a display. If you really want to connect a display to that, you can do through the USB port, and you can have the display as well. And most of these blade servers, they implement CISC architecture that is called complex instruction set computer. So this is the standard way to program the hardware. This is a standard way to execute your instructions on the hardware. So this is a well-known standard for converting your high-level Java code or Python code to some binary code that could be executed on this hardware, which is based on this x86 CISC paradigm. So most of the data centers use this CISC paradigm, CISC type of server blades to create their data centers. Do you know any another paradigm to execute instruction on the hardware? RISC. That's on the mobile phone. The ARM processors are based on RISC. That's called reduced instruction set computers. It's called reduced because it consumes for the same thing less number of instructions. That's why we have it on the mobile phone, because mobile phone doesn't have as much capability as a data center. So normally mobile processors are based on the RISC architecture as compared to the cloud processor, where all the Intel processors are based on CISC architecture. And right, as I said, most of these blade servers don't have, sometimes they can have a hard drive attached to it, but mostly that's not the practice. Mostly they all are connected to a network storage through either Ethernet cable or optical fiber. So if it's connected to Ethernet cable, normally they implement NAS, which is called network attached storage. But now the new trend that is followed by Amazon and Google, they use storage in a network where you connect all your blade servers through optical fibers to a different cabinet that only implements the hard drives, the big storage. It's called as unified SANs, unified storage in a network. So do you understand the difference between optical fiber-based network as compared to Ethernet? If you have done the computer networking module, you will know. Yeah? I mean, what will be the difference in the interface if I connect a storage device on the Ethernet as compared to optical fiber?
I mean, there's a fiber cable that comes out.
The speed.
Oh.
The speed is one of them, and also fiber has longer distance in terms of light signal, because it works on the light. The fiber can send data up to 5 miles as compared to Ethernet, which is few hundred meters. So, for example, they can implement the storage device in a sub data center which is 1 kilometer away through optical fiber network, because that optical fiber is fast as well as it has long distance reach in terms of sending the signals. So that's why they're implementing a SAN, storage in a network based on the optical fiber, because it can just go long way and you can actually disaggregate your computing servers from your storage servers. And that is very nice, because then you don't have to worry about optimizing both storage and computing on the same blade server. It's less complicated if you have both completely isolated in 2 different racks or in 2 different data centers. And of course, you need a nice, clean way to network them together. That's why they use optical fiber, not Ethernet, because Ethernet is slower and it has reach of maybe max 50 meters or 100 meters. But optical fibers can go up to 1 or 2 miles in terms of reachability, and they have much better speed. Right, so now we study about data center server blades, data center storage, and now the most important thing I said, okay, how do we connect these server racks together? How do we connect the server rack to the storage racks? So what is the main goals behind a data center network? How do we create a data center network? So how many networking models you guys know about? Have you heard about these topologies in your past modules?